I want you to imagine something with me for a second.
Okay, I'm ready.
Put yourself in this exact scenario, right? You are walking through a cold, misty, northern European wetland.
Oh, so setting a spooky scene right away.
Exactly. The air is heavily damp, and it smells intensely earthy, like almost sharp with the scent of decaying vegetation.
Yeah, that really distinct peat smell.
Right, and you are out there digging into the peat. You're cutting these dense, wet blocks of earth to dry for winter fuel.
Which is incredibly backbreaking work, by the way.
It really is, just exactly like your family has done for generations out there. So you swing your spade down, and it hits something.
Mm-hmm.
But it isn't a root, and it isn't just a clump of mud. You drop to your knees, you scrape away the dark, wet earth with your bare hands, and suddenly you just freeze.
Because of what you see.
Exactly,
Yeah.
because you are staring directly into the perfectly preserved face of a human being.
It is, honestly, an arresting image.
Right. It's not some bleached white skeleton. It is an actual face.
With the skin completely intact.
Yeah. The eyes are softly closed. There's visible individual hair stubble on the chin.
That's the part that always gets me, the stubble.
I know, it's wild. And the skin has this deep, rich, almost leather-like chestnut hue. So in that moment, your heart drops. You just panic.
Of course you do.
You think you've just uncovered a hidden crime scene, like a murder victim buried maybe last week.
It's the most natural assumption in the world.
But the wild truth is, the person you are looking at hasn't taken a breath for over 2,000 years.
It is arguably one of the most visceral, time-bending experiences a human being can ever have in the archaeological record.
100%.
I mean, coming face-to-face with a bog body, the level of preservation is so profound, so biologically impossible seeming, that it completely tricks the modern eye.
It really does trick you.
It collapses millennia into milliseconds. You are looking at an Iron Age individual, but your brain is screaming that this person just went to sleep.
And that profound illusion, right, that perfect preservation is exactly what we are going to explore today.
It's going to be a fascinating deep dive.
It really is. We've gathered a massive stack of sources for you today. We're talking detailed archaeological theses,
Yeah.
dense biochemical research articles.
Some very dense chemistry in there, yeah.
Oh, extremely dense. And also historical accounts from the people who actually pulled these bodies from the mud.
Which are incredible to read.
Truly. And our mission for this deep dive is to trace the complete chronological story of bog bodies.
Right, from discovery to the modern lab.
Exactly. But we aren't just going to list off who was found where. We want to understand the how and the why.
Because the mechanisms are just as important as the discoveries themselves.
Definitely. So we're going to start from those terrifying initial discoveries that literally baffled local homicide detectives.
And then move into the environment.
Yeah, we'll unpack the miraculous, almost accidental chemistry of the bogs that preserved them in the first place.
And the narrative doesn't stop in the mud, you know. The overarching theme of our sources is that while these bodies were essentially frozen in time, our understanding of them is constantly evolving. Every time humanity develops a new scientific tool, whether it's advanced medical scanning or 3D digital landscape modeling.
We just go right back to these exact same bodies.
Exactly. We go back to them and they reveal a completely new layer of their reality.
It's like reading a book where the text magically changes every time you put on a new pair of glasses.
That's a great way to put it.
And this matters to you, the listener, because this isn't just a grim, morbid anatomy lesson.
No, not at all.
It is a masterclass in how nature can accidentally preserve history. It's a testament to how we, as a society, constantly refine our scientific methods to listen to the voices of the deep past.
Well said.
Okay, let's unpack this. Take us back to the moment of discovery. Set the scene for us in May 1950 near Silkeborg, Denmark.
So May 1950 is just a massive watershed moment for modern archaeology.
Right.
You have these two brothers, Viggo and Emil Hutchgaard, and they're out cutting peat in a raised bog called Biel-Olskovdal.
Biel-Olskovdal. Did I say that right?
Close enough. But anyway, this was a very common practice. Peat was their primary fuel source, right?
Right. They used it to heat their homes.
Exactly. So as they are digging their trench deeper into the bog, they uncover a body. And the preservation is so startling, so immaculate.
Complete with eyelashes, right?
Complete with eyelashes, fingernails, and that famous stubbled chin you mentioned earlier. It was so real that they don't think, oh, wow, archaeology.
They instantly assume they found a recent tragic murder victim.
Exactly. They drop their tools and they immediately call the Silkeborg police.
Which, if you really think about it, is the most logical human reaction in the world.
Oh, 100%.
If you or I are digging in the woods and we find a body with skin and hair, we are calling the cops. We are absolutely not calling a museum curator.
Precisely. And the Silkeborg police arrived at the bog completely prepared to investigate a modern homicide.
Like crime scene tape, the whole deal.
Well, they roped it off, yeah. They examined the body, but then they started looking at the environment around the body.
What were they looking for?
They noticed the specific depth of the peat, for one. But more importantly, they looked at the stratigraphy.
The layers of the earth.
Right, the layers of the earth. The layers of peat directly above the body were completely unbroken.
Oh. So there was no sign of a freshly dug grave.
Exactly. They showed no signs of modern disturbance. Nobody had dug a hole here recently. And then there was the murder weapon itself.
Right, the noose.
A braided leather noose buried deep into the neck tissue.
That's horrifying.
It is. But because of the unbroken peat, it became rapidly apparent that this was completely out of their jurisdiction. So they brought in archaeologists from the local museum.
And this is the discovery of Tollund Man.
Yes, the famous Tollund Man.
And Tollund Man, the victim of this supposedly recent homicide, had actually died roughly 2,300 years ago.
Sometime between 405 and 380 BC, yeah.
But what really blows my mind reading through these historical accounts is how the scientific community of the mid-20th century reacted to this discovery.
It's a bit shocking to modern sensibilities.
Say the least. I mean, we tend to think of 1950 as a relatively modern, enlightened scientific era, right? But their approach to this priceless artifact was, well, brutal feels like the right word.
It was incredibly invasive, yes. But we have to remember the context of the time.
Right. They didn't know what we know now.
The methods of preservation and analysis were fundamentally crude compared to what we do today. When they transported Tollund Man, they didn't treat him with the microscopic delicacy we would use now.
They just laid him out on a slab, didn't they?
They literally autopsied him exactly like a modern corpse on a municipal medical examiner slab.
That is just crazy to me.
They made massive incisions, opened his chest and abdomen, physically removed his intestines.
You took him right out.
Took them out, examined them on a table, said, yep, the organs are all here, and then essentially stuffed them back inside.
I read that description in the sources and actually cringed out loud.
It's tough to read.
You don't just slice open a 2,000-year-old time capsule.
Yeah.
It's like finding an incredibly rare, locked antique chest. And instead of carefully picking the lock...
You took a crowbar to it.
Exactly.
Yeah.
The early finders treated it like a piece of lost luggage and just smashed it open.
It is very difficult to read from a modern perspective, but, as damaging as the 1950s approach was, it was actually a vast improvement over what happened before that.
Wait, it was worse before 1950?
Oh, much worse. If we look back to the early 1900s, for instance, the experiments conducted by a Danish forensic pathologist named Ellerman around 1913.
Okay, what did Ellerman do?
His primary method of conservation was simply to dry the bodies out.
Wait, they just let them sit in the open air?
Yes, they would take these perfectly preserved, waterlogged bodies out of the protective bog environment and simply let the water evaporate at room temperature.
But that would ruin them.
Completely.
Yeah.
Because waterlogged tissue isn't like a wet towel, the water is actually structurally supporting the individual cells.
Oh, I see.
When you allow it to evaporate rapidly, the cell walls collapse and shrink catastrophically.
So they just withered away.
They essentially turned these incredible, fleshy, three-dimensional human beings into hard, distorted, cardboard-like figures.
That is tragic.
They possessed zero understanding of the complex chemical stabilization required to preserve ancient tissues once they were removed from the bog.
So if the early investigators, like the police in 1950, were so utterly convinced these were recent crime scenes,
Right.
and the early scientists were just kind of winging it, drying them out like jerky,
Essentially, yes.
what was the definitive scientific clue that firmly pulled these bodies out of the modern era and anchored them in the Iron Age?
That's a great question.
Because carbon dating was barely a concept in 1950, right? It was just starting out.
What's fascinating here is how the scientific disciplines had to collaborate to solve that exact timeline problem.
Okay, lay it on me.
You're right. When Tollund Man was found in 1950, radiocarbon dating carbon-14 analysis was in its absolute infancy.
It just wasn't reliable enough yet.
Exactly. So early on, they relied heavily on a technique called pollen analysis, or palynology.
Palynology. Analyzing the pollen in the peat layer the body was encased in.
Yes, exactly.
How does looking at ancient pollen tell you when someone died?
Well, as peat forms, it traps the pollen that blows into the bog from the surrounding landscape year after year.
Oh, like a natural filter.
Right. And different tree species and weeds bloom in different climatic eras. So by taking a microscopic look at the pollen grains in the mud immediately surrounding the body.
They could see what was growing at the exact time the peat formed around him.
Precisely. Botanists could say, okay, we are seeing a massive amount of this specific weed pollen and this specific tree pollen.
Which gives them a time frame.
It perfectly matches the known climate profile of Northern Europe during the early Iron Age.
So the dirt itself was the calendar.
The stratigraphy of the bog acted as a temporal fingerprint, yes.
That is brilliant.
It really was.
Wow.
And shortly after Tollund Man, another famous body, Grobel Man, was discovered in 1952.
Just about 11 miles away from Tollund, right?
Exactly. And by the mid to late 1950s, the radiocarbon dating revolution was finally taking off, and they started dating the bodily tissues directly.
And I'm guessing the carbon dates confirmed the pollen dates.
Perfectly. The dates consistently came back to the Iron Age, generally the centuries just before and after the turn of the first millennium.
Wow.
And once the dates were established, scientists realized the sheer scale of what they were dealing with.
Because there were so many of them.
Right, the incredible abundance of these bodies across Northern Europe in the bogs of Denmark, Netherlands, Germany, Britain, and Ireland.
They were popping up everywhere.
Yes, and they all pointed to this specific ancient window of time. It proved definitively that this wasn't a string of modern serial killings.
It was a massive, widespread, ancient cultural phenomenon.
Exactly.
But let's pause here for a second, because this incredible preservation that was literally good enough to fool modern homicide cops into thinking a 2,000-year-old man was killed last Tuesday.
Yeah, it's astonishing.
It wasn't magic. It wasn't that the Iron Age people had some, secret Egyptian mummification technique they were hiding in the swamps.
No, nothing like that.
It was a highly specific, totally accidental chemical perfect storm.
That's the best way to describe it.
If you're listening to this and wondering why your own organic waste decomposes in a landfill in a few weeks, but an entire human body survives for millennia in a wetland.
It all comes down to the environment.
Right. It all comes down to the bizarre environment of the bogs themselves.
The bog is undeniably the true protagonist of this story.
Okay, I love that.
But to understand the chemistry, we have to make a crucial environmental distinction right away, because not all wetlands are created equal.
Wait, really?
Oh, absolutely.
Yeah.
If we want to understand preservation, we have to differentiate between fens and raised bogs.
Okay, break that down for us. Because honestly, before reading these sources, I just pictured a swamp and assumed it's all the same murky, wet mud.
It is a completely different hydrological and chemical reality. Let's start with fens.
Right, what's a fen?
Fens are wetlands that are fed primarily by groundwater.
Okay, so water from underneath.
Exactly. As rainwater hits the earth miles away, it flows underground through rocks, limestone, and mineral soils before bubbling up into the fen basin.
So it's picking up stuff along the way.
Huge amounts of dissolved minerals, especially calcium. And because of this high mineral content, fen water is relatively neutral or even slightly alkaline.
And how does an alkaline fen treat a human body?
It destroys the soft tissue.
Completely.
Completely. If you place a body in a fen, the bacteria thrive in that neutral environment, and the flesh, skin, and organs will completely rot away.
So no perfect faces.
No. However, the mineral-rich water will beautifully preserve the calcium structure of the bones.
Oh, interesting.
Norway, for example, has extensive wetlands, but geologically they tend to be fens.
So what do they find in Norway?
Norway has yielded about 15 bog body finds, but they are all completely skeletonized remains.
No skin.
There is no skin, no hair, no faces, just bone.
But the iconic bodies we are focusing on, Tollund Man, Grobel Man, they are the exact opposite.
Precisely.
I mean, they have basically no hard bones left at all, but their skin is utterly perfect.
Right. And that opposite outcome occurs because they were placed in a fundamentally different environment. Raised bogs.
Raised bog, okay.
Raised bogs are known scientifically as ombrotrophic bogs.
Ombrotrophic.
Ombrotrophic literally means cloud-fed or rain-fed.
So no groundwater.
Zero groundwater. Over centuries, the decaying plant matter builds up so high that the surface of the bog actually sits up like a dome.
Oh, I see. It literally raises up.
Yes, it is completely isolated and elevated above the local groundwater table.
So they are entirely cut off from the Earth's minerals. They only drink rain.
Exactly. And rainwater contains almost no dissolved minerals.
Okay, so it's a mineral-starved environment.
Yes, and this mineral starvation allows one very specific, highly aggressive plant to completely take over the ecosystem.
And this is the star of the show.
This is the crucial ingredient to the entire bog body phenomenon. Sphagnum moss.
Sphagnum moss, the tiny green architect of the perfect storm.
It is a brilliant piece of biological engineering.
How does it work?
Well, as sphagnum moss grows in these dense, overlapping saturated carpets, it actively acidifies everything around it.
Why does it do that?
To kill off competing plants, it wants the bog all to itself.
That's pretty vicious for a moss.
It is, and it does this through a process of ion exchange.
Okay, chemistry time. Walk us through it.
The moss absorbs any stray nutrient cations, like calcium or magnesium, that happen to fall in the rainwater.
Right.
And in exchange for absorbing those nutrients, it pumps out hydrogen ions into the water.
And hydrogen ions are exactly what make an acid.
Precisely. It progressively strips the water of nutrients and replaces them with pure acidity.
So it's basically terraforming its own environment.
Exactly. We are talking about a remarkably harsh environment. The pH in the deeper layers of a raised bog sits between 3.2 and 4.5.
Wow. For context, if you're listening, a pH of 3 is roughly the acidity of household vinegar or grapefruit juice.
It is extremely acidic.
So these bodies are soaking in a giant natural vat of vinegar.
Yes. And that extreme acidity creates conditions that are deeply hostile to most normal biological decay.
Which makes sense.
Furthermore, because the dense peat cuts off air circulation, once you get below about 40 centimeters from the surface, the oxygen disappears almost entirely.
So it's acidic and there's no oxygen.
Right. Now, for a very long time, early researchers assumed this combination was the entire secret.
High acid plus zero oxygen equals no bacteria.
Exactly. And no bacteria means no rotting.
Which sounds completely logical on the surface. We know bacteria need oxygen to breathe, and most of them hate acid. So, case closed, right?
It sounds logical, but our sources point out that it is actually a massive historical misconception.
Oh, really?
The anoxic deep region of the peat is absolutely not completely sterile.
Wait, it's not?
Not at all. In fact, back in 1929, two researchers named Wexman and Stevens ran microbiological tests.
Okay, and what did they find?
They demonstrated that the anaerobic layers of deep peat actually contained between 10,000 and 1 million living bacterial cells per gram of wet peat.
Wait, hold on. Up to 1 million bacteria per gram
Yes.
in this supposedly dead, sterile environment.
Exactly. But these are specialized extremophiles known as acidophilic anaerobes.
Acidophilic, meaning they love acid.
Right. They have evolved to love high acid, and they don't need oxygen to survive.
Oh, wow.
They are perfectly capable of functioning and breaking down organic matter in those exact conditions.
Okay, so if the bog is actually swarming with 1 million acid-loving bacteria per gram, why didn't they eat Tollund man? What stopped them?
That was the mystery that stumped biochemists for decades.
Because clearly something stopped them.
The missing chemical link, the real preserving agent, is a complex polysaccharide called sphagnum.
Sphagnum, spelled with an N at the end.
Yes, this mechanism was foundational work detailed by a Norwegian biochemist named Terence Painter in 1991.
Okay, so what is sphagnum?
Sphagnum is a pectin-like carbohydrate polymer that is structurally embedded directly in the cell walls of the sphagnum moss leaves.
So the moss isn't just making the water acidic, it holds a specific preservative chemical inside itself?
It does, but it's a tricky mechanism.
Oh, so?
While the sphagnum moss is alive and growing on the surface, the sphagnum is locked tightly into the plant's cell walls.
Okay.
It is biologically inert. It can't preserve anything.
So living moss won't preserve a body?
No. But as the moss dies and gets buried, slowly converting into dense peat over hundreds, even thousands of years,
Right.
a spontaneous chemical breakdown occurs. It's a process called autohydrolysis,
Autohydrolysis.
and it is continuously catalyzed by the bog's natural acidic water.
So the dead moss is basically slowly digesting itself.
Exactly. And as it breaks itself down over a period of roughly 2,000 to 3,000 years.
Wow, that is a slow release.
Very slow. It continuously liberates this active sphagnum polymer into the surrounding bog water.
Oh, I see.
So, if a body is thrown into an active, deep raised bog, it isn't just sitting in acidic water.
It's basically steeping in it.
It is being perpetually bathed in a dilute, highly reactive solution of sphagnum that is slowly, constantly leaching out from the progressively older peat layers surrounding it.
Okay, so the body is soaking in sphagnum. What does this chemical actually do to human flesh to stop 1 million bacteria from eating it?
It initiates a direct chemical attack on the collagen.
Which is the primary structural protein in human skin.
Exactly. And the specific mechanism of this attack is known as a Maillard reaction.
Wait, I have to stop you there.
I thought you might catch that.
Sugars reacting with amino acids. A Maillard reaction.
Yes.
Think about your own kitchen for a second. The Maillard reaction is literally the exact same chemical process that browns the crust of a loaf of sourdough bread in the oven.
It is the exact same chemistry.
It's what creates that perfect, dark, savory crust when you sear a steak in a hot cast iron pan. The heat forces the sugars and amino acids to violently cross-link. Are you telling me that nature is essentially baking and tanning these human bodies into dark leather, just using time and bog chemistry instead of oven heat?
That is a phenomenal realization, and biochemically, it is remarkably accurate.
That is insane.
It isn't just passively staining the skin brown like a dye, It is a genuine, aggressive, structural modification of the tissue's fundamental proteins.
That's changing the skin on a molecular level.
It tans the collagen in precisely the same chemical sense that animal hide is tanned to make a leather jacket.
Wow.
The skin becomes intensely hardened, deeply darkened, and structurally unrecognizable to the enzymes that bacteria use to digest food.
So the bacteria just don't recognize it as food anymore.
Exactly. The bacteria are there, but the skin has been turned into a plastic-like polymer they cannot eat.
That is brilliant.
This is exactly why bog body skin universally turns that deep coffee brown or chestnut color.
Because it's literally tanned leather.
Yes. And because the bonds formed by Sphagnum are highly stable covalent bonds, they actually resist breaking down far better than conventional historical leather tanning methods that relied on tree bark tannins.
That is incredible. But
Yeah.
it brings up a really bizarre paradox.
What's that?
Well, the skin turns into this tough, indestructible, biological leather armor, right?
Right.
And the hair survives perfectly, which makes sense because hair is made of keratin, which is naturally highly resistant to acid.
Exactly.
The fingernails survive.
Yeah.
But the bones,
The bone.
the hard, solid, calcified bones that normally survive for millions of years in the fossil record, they turn to soft rubber, or they dissolve completely into nothing.
They do.
Why does the soft stuff survive and the hard stuff vanish?
Because Sphagnum is a multi-tool. It isn't just a tanning agent.
What else does it do?
It is also a remarkably powerful chelating agent.
Chelating agent. What does that mean in this specific context?
A chelating agent is a molecule that essentially acts like a microscopic claw. Yeah, its chemical structure is perfectly designed to grab onto and bind with multivalent metal cations.
Okay. And in a human body, that means?
Specifically, in this biological context, calcium.
So it actively hunts for calcium.
It hunts for calcium with a ferocious affinity.
Wow.
Because the bog water is perpetually saturated with this free-floating sphagnum.
And because sphagnum is desperate to bind with calcium.
It slowly, relentlessly pulls the calcium phosphate out of the human
It
skeleton.
just rips it out.
It literally plucks the minerals out of the bone matrix, molecule by molecule, and washes them away into the vast volume of the bog.
So it dissolves the very mineral that gives bone its rigid architecture in the first place.
Yes. The bones become completely, entirely decalcified.
That is so wild.
They turn soft, pliable, and rubbery, much like cartilage, while the surrounding skin remains tough and perfectly intact.
It's so backward from normal decay.
It is, and this is exactly why, when archaeologists pulled Grobala Man out of the bog in the 1950s, his bones had warped, folded, and compressed dramatically.
Oh, because they couldn't support his weight anymore.
Imagine the sheer weight of tons of wet, dense peat pressing down on a skeleton made of wet rubber for 2,000 years.
It's like a bizarre magic trick. It's like taking the structural steel scaffolding out of a skyscraper without breaking a single window.
That's a really good visual.
Right. Leaving the wallpaper perfectly intact while the building slowly squishes downward.
Exactly.
But for this entire perfect storm to work, the tanning, the chelation, the acid, the timing of the death had to be incredibly precise, didn't it?
Very precise.
Because you can't just toss a body into a bog on a hot July afternoon and expect a slow chemical tanning reaction to outpace a swarm of hungry bacteria.
Exactly. The biological math doesn't work in the summer.
Okay, so what are the rules?
There are extreme, non-negotiable time and temperature constraints. The Sphagnum chemistry is powerful, but it is slow.
Right, you said it takes a while.
For soft tissue preservation to occur, the ambient water temperature of the bog had to be below 4 degrees Celsius.
4 degrees, that's about 39 degrees Fahrenheit.
Yes. And it had to be that cold at the exact time the body was deposited.
4 degrees Celsius.
Yeah.
That's essentially the exact temperature setting inside your kitchen refrigerator.
Precisely. Cold water forcefully suppresses the microbial metabolism in the critical hours and days immediately following death.
It freezes them out.
It hits the biological pause button on putrefaction.
Oh, that makes so much sense.
This temperature delay buys the necessary time for the sphagnum molecules to physically penetrate the outer layers of the dermis and begin its tanning action.
Before the bacteria can wake up and start eating.
Exactly. Before the endogenous bacteria in the gut, or the acidophilic bacteria in the bog, can establish a foothold and begin necrosis.
How long is that window?
Forensic experiments have shown there is roughly a 48-hour critical window.
So 2 days.
Yes. If you place a body in a bog in the middle of summer, the warm water allows the bacteria to reproduce exponentially.
And they just destroy it.
They will completely destroy the soft tissue before the sphagnum can tan it.
So by looking at this complex chemical requirement, what does that instantly tell us about the deaths of Tollund man and Grobill man?
Well, it proves, beyond a shadow of a doubt, that they were winter or very early spring deposits.
Because they had to be placed in a freezing bog?
The entire bog was acting as a literal, functioning refrigerator, holding their bodies in thermal stasis just long enough for the slow chemical tanning process to lock their tissues into eternity.
It is staggering when you actually stop and think about all the environmental variables that had to align perfectly for us to see these faces today.
It really is a marvel.
The geological lack of groundwater, the reliance on purely acidic rain, the aggressive dominance of the sphagnum moss,
The 3,000-year autohydrolysis of the sphagnum.
the covalent-Maillard reaction, tanning the skin, the chelations dissolving the bones, and the temperature having to sit below 4 degrees Celsius.
It is an absolute masterpiece of accidental chemistry.
A masterpiece. But because of that very specific chemistry, specifically the decalcification of the bones while preserving the skin, these bodies suffered incredibly bizarre physical distortions, as we mentioned.
They did.
And for decades, those taphonomic distortions severely misled scientists about how these people actually died.
Yes. Which marks the necessary shift in our narrative, moving away from gross anatomy and into the realm of microscopic marvels.
Right. The technological leap of the late 20th century.
Exactly.
So let's move forward into the late 20th and early 21st centuries.
Mhm.
We thankfully evolved past the 1950s police autopsies, pulling out intestines on a steel table.
Thankfully, yes.
And we've entered a completely new era of non-invasive analysis. How did modern technology like CT scanning fundamentally correct the historical record regarding these deaths?
Well, to understand the correction, we first have to look at the original errors.
Okay, what did they get wrong?
If we look at the initial forensic interpretations of bodies like Grobill man, found in 1952, or Boramos woman, found in 1948, the scientific conclusions were heavily and understandably influenced by what the naked eye saw.
What did they see?
When researchers looked at Grobill man, they saw a skull that was massively fractured and legs that appeared to be broken in multiple places.
Yikes.
Boramos woman had a completely crushed face, and the back of her head appeared to be violently scalped.
So the early mid-century assumption was that these people were victims of extreme torturous violence.
Exactly. It birthed what was known as the overkill theory.
The overkill theory.
The dominant anthropological idea was that these people weren't just executed, they were brutally beaten, struck with multiple heavy weapons.
Like it was some sort of punishment.
Perhaps as a severe punishment for a horrific crime, or as a highly aggressive, violent ritual sacrifice to angry gods.
So we spent 50 years thinking these ancient people lived and died in a state of horrific, sadistic torture.
We did.
But then we actually looked closer.
Yes. When researchers applied modern 3D CT scans and dual-energy X-ray scans to these bodies in the late 90s and early 2000s, the overkill narrative completely unraveled.
How so? I mean, a bone is broken, right? How does a scan change that?
Because a bone in a bog body isn't a normal bone anymore.
Oh, right. The chelation.
Exactly. Evaluating bog bodies with CT technology is incredibly difficult because of what we call diagenetic changes.
Diagenetic changes, meaning the chemical alterations we just talked about.
The taphonomic damage, yes. Because the bones are completely demineralized by the sphagnum, they don't show up clearly and crisply on X-rays like a healthy, modern, calcified bone would.
What do they look like?
They look like ghostly, blurred lines. It's very difficult to interpret.
Oh, man. So how do you read it?
To make sense of it, you have to apply significant computational post-processing to the scan data to extract meaningful 3D images.
You have to clean up the data.
But when researchers finally perfected this technique, when they computationally isolated and mapped the exact nature of the fractures on Grobal man and Boromos woman,
What did they find?
they found that the fracture patterns lacked the characteristic impact signatures of perimortem trauma.
Wait, meaning?
The scans proved these fractures were entirely postmortem.
Post-mortem, meaning they happened years, maybe centuries after the person was already dead.
Right. The crushed face wasn't caused by a violent blow from an Iron Age club.
It was the bog.
It was caused by the immense, unrelenting weight of a mountain of wet peat pressing down on a skull that had been turned to soft rubber.
That makes total sense now.
Boromos woman's scalping wound wasn't a torture device either.
What was it?
It was highly likely caused by the peat cutter's steel spades slicing through the earth during her accidental discovery, or simply the sheer tearing pressure of the shifting earth over 2 millennia.
The overkill theory was an illusion created by geology. It's wild to think that our initial forensic bias painted this picture of a savage, hyper-violent society, when in reality, the earth just squeezed them too hard.
It really shows how dangerous it is to look at ancient evidence through a modern forensic lens without accounting for the profound impact of the environment.
Absolutely. But modern tech doesn't just clear up broad misinterpretations of violence. It reveals details so vanishingly small, it feels almost intimate.
It does.
Let's talk about what happened in Paris in 2015 with Tollund man, because this is amazing.
That is one of the most beautiful examples of cross-disciplinary science.
What do they do?
In 2015, Tollund man's feet were carefully transported to the Natural History Museum in Paris to be analyzed using a technique called endogenous fluorescence.
Endogenous fluorescence. What exactly is that, and why use it on ancient feet?
It is a non-invasive medical imaging technique. It was originally developed in modern dermatology to diagnose superficial skin cancers, like basal cell carcinoma or melanoma, in living patients.
So it's a skin cancer tool.
Right. The technique works by shining very specific wavelengths of light onto the skin.
Okay.
This light excites certain endogenous fluorophores, which are natural biological molecules within the cellular structure, causing them to fluoresce or glow at distinct frequencies.
Oh, cool.
By reading that microscopic glow, doctors can see the cellular architecture and pathologies of the skin without ever using a scalpel to take a biopsy.
And what happens when you shine that highly specialized dermatological light onto the foot of a man who walked the earth over 2,000 years ago? What did they see glowing back at them?
They identified the cellular structure of 3 distinct warts and a small scar on the sole of his foot.
3 warts and a scar. That is unbelievable.
It's a stunning level of detail.
We know he had warts.
Mm.
I think about that. And it completely humanizes him in a way that looking at a glass case never could.
It really does.
He isn't just an abstract archaeological artifact. He's a guy who maybe walked around barefoot in the damp mud a bit too much, caught a common virus, and had a scar from stepping on a sharp rock while out working.
It bridges the gap between archaeological specimen and human being in a very profound, relatable way.
It really does.
And this high-resolution technology goes far beyond the surface of the skin. Let's look at dietary and chemical clues.
Right, the stomach contents.
By utilizing advanced microscopy and chemical analysis on the preserved stomach and intestine contents, we can reconstruct exactly what they consumed in their final hours.
And from what the sources say, it wasn't exactly a celebratory final feast.
No, it rarely was. Tollund man's last meal, which digestion rates tell us was consumed roughly 12 to 24 hours before he was hanged, was a very specific utilitarian porridge.
What was in it?
It was made of barley, linseed, and a massive variety of wild, foraging weed seeds.
So no meat.
Absolutely no meat and no fresh fruit.
Just a heavy, dense, seedy gruel.
Yes. But if we compare that to Lindow, also known as Lindow man, who was found in Britain, the menu changes significantly.
Okay, what did Lindow man eat?
His last meal included emmer wheat, spelt, and crucially, an unusual concentration of mistletoe pollen.
Mistletoe, like the plant we hang up during the holidays. Is that even biologically edible?
It is actually highly toxic in large quantities.
Oh, wow.
It causes severe gastrointestinal distress and cardiovascular collapse.
So he was poisoned.
Well, in small, highly controlled doses, mistletoe was well known in antiquity, particularly among Druidic and Celtic cultures. to be used as a potent narcotic or a hallucinogen.
A hallucinogen.
Yes. The presence of mistletoe pollen has led researchers to strongly theorize that Lindow man's ingestion of this plant wasn't dietary foraging.
It was highly ritualistic.
Exactly. Perhaps it was administered to induce a trance state or to drug him into compliance prior to his violent death.
That is dark, but incredibly fascinating.
Yeah.
We are mapping the microscopic warts on their feet. We are reconstructing their final, potentially hallucinogenic meals down to the pollen grain. It feels like we can see everything.
It does feel that way.
But with all this incredible omnipotent tech, is there anything the bog completely destroys? What is our blind spot here?
This raises an important question because the reality of the bog is that it giveth and it taketh away.
What does it take away?
Our absolute biggest blind spot, the holy grail that we have struggled to grasp, is DNA.
Why is that? I mean, if the skin is preserved perfectly, and we know from the sources that even brain tissue survives inside the skull, shouldn't the cellular DNA be right there waiting to be sequenced?
You would certainly think so, but the very chemical mechanism that beautifully preserves the macroscopic body, the intense penetrating acidity of the bog, is highly destructive to nucleic acids at the molecular level.
Oh, the acid just eats it.
Over centuries, the acid slowly hydrolyzes and shreds the long, delicate DNA chains into fragments so infinitesimally small that they are virtually unreadable by modern sequencing algorithms.
So they're just shattered.
Yes. For decades, traditional ancient DNA extraction methods, which work perfectly on dry bones found in caves, have failed entirely when applied to bog bodies.
That has to be incredibly frustrating for geneticists.
Yeah.
To have the person sitting right there in front of you, but their entire genetic blueprint has been wiped completely clean by the acid.
It is a massive hurdle. However, scientists are tenacious.
Have they found a workaround?
Because soft tissue and regular bone fail, they are now targeting a very specific, highly fortified part of the human anatomy, the petrous bone.
The petrous bone, what is that?
It is a small, pyramid-shaped portion of the temporal bone located deep at the base of the skull, housing the delicate structures of the inner ear.
Okay.
Crucially, it is the densest, hardest bone in the entire human body.
So it's like a biological safe.
Exactly. The current working hope is that the extreme, unparalleled density of the petrous bone might have acted as a vault, shielding some tiny, fragile fragment of DNA from the penetrating bog acid over the millennia.
Has it worked?
The extraction work is ongoing, incredibly difficult, and not always successful, but it represents our best and perhaps final hope for unlocking bog body genetics.
Okay, so DNA is a massive struggle. But even without a genetic blueprint, we are still pulling incredibly detailed chemical signatures out of them, right?
Yes, absolutely.
Specifically from their hair. I've always found isotope analysis fascinating. How does that work, and what does it tell us?
So we are talking specifically about strontium isotope analysis.
Strontium, okay.
Strontium is a naturally occurring trace element found in the Earth's bedrock.
Okay.
As groundwater flows through the rock, it picks up a specific ratio of strontium isotopes that is completely unique to that localized geographic area.
Like a geological fingerprint?
Exactly like a fingerprint. Plants absorb that water, local animals and humans eat the plants and drink the water.
And it gets into our bodies.
Yes. Over time, the strontium physically replaces a tiny amount of calcium in the structure of our growing bones and hair.
So, if I understand this correctly, your hair is basically a chronological chemical receipt of the exact dirt you've been living on.
That is a perfect way to describe it. And because human hair grows at a relatively steady, predictable rate,
You can track time.
you can take a single long strand of ancient hair, chop it into microscopic segments, and test each segment individually.
Wow.
This gives you a chronological, month-by-month timeline of exactly where a person lived and moved.
That is unreal. So what happened when they did this to Tollund man?
When researchers applied this to Tollund man's hair, the isotopic receipt was shocking.
What did it say?
They discovered that for the vast majority of his life, he lived in a geographical zone at least 40 kilometers away from the Bjoldskavdal bog, where he was eventually killed and deposited.
Wait, 40 kilometers?
Yes. It was only in the last 4 to 6 months of his life that he abruptly moved to the area near the bog.
Now, 40 kilometers might not sound like much to us today. That's a half-hour drive on the highway.
Right, but back then...
In the Iron Age, through dense forests and wetlands, on foot, that is a significant, intentional relocation.
Very significant. And Tollund man is not an isolated case. No. Isotopic analysis of Holdremos woman, another famous Danish bog body, showed evidence of even more extensive long-distance travel across different geological zones just before she died.
Does this data force us to change our fundamental view of who these people were?
I think it absolutely has to.
We usually think of these bog bodies through the lens of local village-level sacrifices, like a tight-knit community choosing someone from among their own ranks to appease the local spirits.
That was the standard theory for a long time.
But if they are traveling vast distances right before their execution, who are they? Were they religious pilgrims making a final journey to a sacred site?
Maybe?
Were they prisoners of war or captives brought in from a neighboring conquered tribe?
It completely upends the traditional simplified narrative of the local scapegoat.
It really does.
If they were sacrificed, the data suggests the physical journey itself may have been a critical component of the ritual. Their movement across the landscape meant something vital to the people who killed them.
The landscape. Okay, that feels like a big shift in how we look at this.
It is, and that realization brings us to a massive, long overdue paradigm shift in how modern archaeology is approaching these bodies.
Where are we shifting to?
For centuries, we have focused with absolute laser precision on the bodies themselves. We mapped their microscopic warts, we analyzed the seeds in their stomachs, we sequenced the isotopes in their hair.
We stared at the body.
Exactly. But as one of our key sources, the groundbreaking 2019 thesis by Dr. Zena Marie Zeinalabdin argues forcefully, focusing only on the body leaves a massive glaring blind spot, the landscape itself.
Right. So modern science has brilliantly mapped the interior of these bodies, but Zeinalabdin is saying we've essentially ignored the ream they were found in.
Exactly.
We have spent decades staring at the artifact and ignoring the museum. We need to zoom out.
Yes. Zeinalabdin's research is a masterclass in what we call landscape archaeology.
Landscape archaeology.
She argues that there has been a profound systemic historical disconnect between the deep study of the bog bodies and the deep study of the physical geographic environment they were deliberately placed in.
How did she prove this?
To prove how vital this context is, she structurally compared two highly famous bodies from entirely different regions and time periods.
Who did she compare?
Tollund man from Denmark and Lindow II from Britain.
Okay, let's contrast them, because if you just read the autopsy reports on paper, their deaths look incredibly different.
Fundamentally different. Let's look at the pathology.
Okay, start with Tollund man.
Tollund man was found in Djælskovdal bog in Denmark. He was hanged with a braided leather noose, which caused asphyxiation.
Right, we talked about the noose.
But beyond the hanging, there was a distinct, notable lack of other trauma. No broken bones, no defensive wounds.
So just the hanging.
Furthermore, the way he was placed in the bog suggests immense care.
He looked like he was sleeping.
Yes. He was laid gently on his side in a fetal sleeving pose. His eyes and mouth were carefully closed, and he was placed inside an old, dry, peat-cutting trench that later flooded over.
That's fascinating.
There is a palpable sense of quietude, of deliberate, almost gentle placement after the execution.
And then you have Lindow II.
Yes. Lindow II, found in Lindow Moss in Cheshire, Britain, suffered what appears to be extreme, terrifying violence.
It's the total opposite.
It is. He was struck violently on the top of the head with a heavy, V-shaped axe-like weapon, fracturing his skull.
Oh my God.
His neck was viciously garroted. They found a twisted animal sinew cord deeply embedded in his neck tissue, tightened so forcefully it broke his cervical vertebrae.
That is brutal.
And if that wasn't enough, he had a deep, massive incisional wound to the front of his neck that completely severed the jugular vein.
So they hit him, strangled him, and cut his throat.
He also had a broken rib and a suspected stab wound to the upper chest.
It is a staggering contrast. Tollund man is gently laid to sleep after a hanging, and Lindow II is subjected to a terrifying, multi-stage, frenzied execution.
Yes, different countries, different centuries, vastly different methods of death.
So why would Zeinalabdin choose to compare them? They seem like they have nothing in common.
Because despite their obvious regional, temporal, and pathological differences, Zeinalabdin's advanced spatial analysis reveals a profound, deeply shared similarity.
What similarity?
A shared similarity in where they were placed within their respective landscape.
Okay, how did you figure that out?
To prove this connection, her research team didn't just look at maps. They generated entirely new environmental data using auger coring.
Auger data. What exactly is that for those of us who aren't field geologists?
An auger is essentially a long, hollow steel drill that you drive deep into the earth by hand to extract an undisturbed vertical core sample of the soil.
Oh, like taking a tiny cross-section of the dirt.
Exactly. By taking hundreds of these core samples across a massive grid over the landscape, you can map the hidden layers of peat, sand, and clay buried deep beneath the surface.
That sounds like a lot of work.
It is. Zynalabdin took all this core data and fed it into a computer to create highly precise 3D digital elevation models, or DEMS.
DEMS.
Yes, of the pre-peat geological basins.
Pre-peat?
She essentially digitally peeled back thousands of years of accumulated peat to reveal the original naked shape of the land exactly as it existed before the bogs even began to form.
Wow. So she's not looking at the flat swamp we see today. She's looking at the ancient valleys and bowls in the earth that eventually filled up with moss and water.
Precisely. She computationally reconstructed the development of the hydrosphere,
Hydrosphere.
the complex vegetational and hydrological history mapping how the wetland grew from its inception.
Okay, so she rebuilt the ancient landscape in 3D.
Hmm.
And what did her models reveal?
It was staggering. Both Lindow II and Tollund, despite being separated by hundreds of miles and hundreds of years,
Yeah.
they were deliberately placed in the absolute deepest, most remote, central parts of their respective pre-peat basins,
The absolute center.
furthest away from the dryland edges.
So they weren't just tossed into the shallow end of the swamp near the tree line.
No. On Lindow Moss, Zynalabdin's models mathematically proved Lindow II was placed approximately 164 meters from the northern edge of the contemporary peatland and 169 meters from the southern edge.
He was dead center.
Tollund was deposited in a slightly shallower, localized area of his underlying basin, but crucially, his coordinates place him right in the central heart of the bog, almost exactly equidistant from the northern and southern dryland edges that existed during the Iron Age.
And what was the terrain actually like to get to that central point? Was it a nice, firm stroll out to the middle?
It was the exact opposite. Her environmental analysis of the cores, looking at microscopic plant macrofossils, ancient pollen, and preserved insect remains.
Right.
It allowed her to reconstruct the surface conditions. The surface wetness of these specific bog centers during the Iron Age was incredibly treacherous.
How treacherous are we talking?
These are unstable areas of open, freezing water, shallow, deceptive peaty pools, and deep, sinking mud.
Sounds like a nightmare.
Walking across this area, an individual would have sunk knee-deep or more into freezing, acidic water with every single step. Accessibility across the bog to these central locations would have been physically exhausting, disorienting, and highly perilous.
So, if we synthesize all of this, if I try to vividly visualize the sheer physical effort required to execute this action,
Go ahead, picture it.
walking into the dead center of a freezing, treacherous bog, sinking up to your knees in freezing acid water, struggling for balance, all while carrying or dragging the dead weight of a human body for hundreds of meters.
It's an intense image.
That completely shatters the idea of a crime of convenience.
Entirely.
If you murder someone in the village and just want to quickly hide the body so you don't get caught, you bury it in the soft dirt in the woods behind your house.
Yes, you don't go on a dangerous trek.
You absolutely do not mount an exhausting, dangerous expedition into the center of a freezing swamp. It's the equivalent of hiking into the deep, trackless, freezing wilderness today, miles off the trail, just to leave something behind.
If we connect this to the bigger picture of Iron Age society, it changes our fundamental anthropological understanding of these events.
It has to.
The sheer physical reality of the landscape analysis proves these weren't opportunistic muggings where bodies were lazily dumped on the edge of town to hide the evidence.
No way.
The profound isolation, the intense lack of accessibility, and the immense physical effort required to reach the center prove these depositions were highly planned, deeply deliberate communal actions.
And Zynalabdin didn't just look at the wet parts of the map. She also looked at the dry land surrounding the bogs, right? The human footprint.
She did. And the results of that survey are incredibly telling. She evaluated the known cultural archaeology within a wide 5-kilometer radius of both bogs.
What did she find?
When she mapped it, she found that for a radius of 1.8 to 2 kilometers immediately surrounding both Lindow II and Tollund, there is a total conspicuous absence of contemporary cultural archaeology.
Meaning what exactly? No houses?
No settlements, no agricultural farmsteads, no weapon hoards left as offerings, no normal cremated burials.
Nothing.
It was an absolute archaeological wilderness, a deliberate dead zone. The people who buried Tollund Man and Lindow Man deliberately selected locations that were entirely geographically set apart from everyday, mundane cultural life.
They took them off the map. They removed them from the world of the living entirely.
Exactly. The sheer isolation of these specific spots within the already dangerous, difficult bog environment elevates these locations to the status of special or sacred isolated places.
It's almost like the journey was the point.
That's a strong theory. The grueling effort to reach them wasn't an unfortunate byproduct of wanting to hide a body. The effort, the danger, and the isolation were likely the entirely intentional point of the burial.
The terrifying journey into the center of the sinking landscape was a vital ritual act in itself.
Was it a sacred portal to the gods requiring a treacherous journey? Or was it a desolate prison for an outcast that never wanted to return?
We might never know.
The landscape doesn't give us the final answer, but it tells us the question is much bigger than just the body.
Think about that. If you are listening to this right now, think about how incredibly easy it is for us, even for highly trained scientists, to focus purely on the shiny object.
We all do it.
In this case, a perfectly preserved human face sitting in a climate-controlled glass museum case. And we completely missed the context of the room it was found in.
It's a very common human failing.
By just staring in awe at Tollund Man's eyelashes and debating his warts, we missed the massive reality that his people carried him 2 kilometers away from anything resembling human civilization into the dead center of a freezing, sinking, terrifying landscape just to lay him gently to sleep.
It's a profound reminder for all of us to zoom out in our own learning. Context is everything.
It is the ultimate lesson of bog body research.
The biology of the body tells us how they died, but the geography of the landscape tells us why their death mattered to the people who put them there.
Man, we have covered an incredible expansive arc today.
We really have.
We started with the sheer visceral panic of Danish peat cutters in 1950, staring down into the fresh face of a 2,000-year-old man.
Then we waded deep into the invisible acidic warfare of sphagnum moss.
And that millennia-long Maillard reaction that literally baked these bodies into indestructible leather.
We looked through the high-tech, glowing 3D scanners in Paris to find ancient scars.
And finally, we zoomed all the way out to see the lonely, deliberate, treacherous wilderness where these ancient people were laid to rest.
And as we conclude this deep dive, I want to leave you with a rather haunting consideration derived directly from the environmental data in our sources.
Okay, what's that?
Many of the great lowland bogs, particularly in regions like Britain and Ireland, have been systematically and heavily drained from modern agriculture over the last few centuries.
Because they need the land for farming.
We are digging deep trenches, pumping the water out, and turning ancient saturated peatland into dry, arable farmland.
Which fundamentally destroys the architecture of the bogs.
It permanently destroys the anopsic, highly acidic environment we spent this entire time unpacking.
The perfect storm is ruined.
As we drain these ancient wetland ecosystems, we aren't just altering the modern climate, though peat bogs are massive carbon sinks, so the environmental impact is severe.
But archaeologically...
Archaeologically, we are actively turning off nature's greatest refrigerators.
Oh.
Once a bog is drained of its water, oxygen floods back into the deep peat. The aerobic bacteria return in massive numbers.
And the decay starts.
And any ancient bodies perfectly hidden in that peat that haven't been discovered yet will rapidly, irreversibly rot away into nothing.
We are literally unplugging the machine before we've seen everything inside it.
We are effectively ending the chance for future generations to ever look another ancient ancestor in the eye.
That is tragic.
It forces us to ask a difficult question. What other voices, what other perfectly preserved faces are silently disappearing into the drained soil right now, rotting away before we even have the technology to hear what they have to say?
That is a chilling thought to end on. We are losing the ultimate time capsules before we even know they are buried in the yard. Thank you for joining us on this deep dive. Keep asking questions, keep looking at the wider landscape around the facts, and above all, keep your curiosity alive.